This work presents text-to-interaction, a framework to establish safe and preferable interactions between humans and robots. Let's imagine a user requests that the robot hands them a screwdriver. State-of-the-art approaches can effectively plan a sequence of skills that would fulfill this request. However, these approaches usually only optimize for task success, so all of the shown solutions would be considered equal. Based on this example, it is clear that if we work together with humans, we not only have to answer the question, what should the robot do, but also how should the robot do it. Traditionally, to answer this question, we would show the user a number of different executions and ask them for their preferred solution. This can be quite time intensive, and we have to repeat this process for every new task. Naturally, this drastically reduces immersiveness and engagement when working with robots. We therefore propose text-to-interaction, a framework that incorporates user preferences and the robot plan in a zero-shot manner. Upon a user instruction, we query a large language model to generate a task plan, a set of parameters that adjust the safe controller of the robot to the comfort of the user, and a set of Python functions that evaluate if the robot action aligns with the user preferences. Our first baseline represents most state-of-the-art task and motion planning approaches, which only optimize for task success and neglect human preference. Baseline 2 treats both task success and human preference as additive rewards, which can lead to either successful but undesired execution or desired but unsuccessful ones. Our approach treats task success and user preference as a combined probability, which allows us to find solutions that satisfy both requirements. In the shown example, the preferred execution might be that the robot grasps the screwdriver by the rod and hands it over with the handle facing towards the human. Here, our first baseline would select the first action sequence because grasping the screwdriver by the handle maximizes the chance of succeeding. The second baseline might prefer the second action sequence, which maximizes user satisfaction but is unlikely to succeed. Only text-to-interaction would select the third sequence, which is both likely to succeed and satisfy the user requirements. We evaluated our approach in a real-world user study. The user study consisted of 4 stages. In stage 1, we demonstrated 3 different sets of controller parameters to the user. The beginner mode is quite slow and slows down even further if the user gets closer. The intermediate mode is faster and slows down slightly earlier. The expert mode is close to the robot's maximum speed, but still requires that the robot is slowed down sufficiently if the user gets too close. After these demonstrations, the participant decides which mode to continue with in the rest of the experiment. In the next stage of the experiment, we demonstrate the behavior of baseline 1, which only optimizes for task success. Here the robot grasps the handle of the screwdriver and hands it over in a position which is easily reachable for the robot. The next stage demonstrates text-to-interaction, which we queried with a predefined user instruction prior to the experiments.
Can you please make sure that I can grasp the handle comfortably and that the full handle is actually graspable?
Now the robot grasps the rod instead of the handle and makes sure that the handle points towards the user. In the final stage of the experiments, we asked the participants for their personal instructions for text-to-interaction.
The screwdriver should be a little bit closer to me because that was quite far away.
Can you make sure that the handle always points downwards and that the robot still gets close to me?
The results of our user study clearly show that the participants enjoyed working with text-to-interaction and preferred it over the baseline. To evaluate the dependency of text-to-interaction on in-context examples, we set up an ablation study. For this, we manually define 10 object rearrangement tasks and their corresponding oracle preference functions. For each task, we then randomly selected 3 of the remaining tasks as in-context examples for the large language model query. We repeated this procedure 3 times per task, leading to 30 evaluation trials with 100 runs per trial. The results showed that text-to-interaction integrates user preferences better than the 2 baselines while maintaining a high success rate. These results are exemplified in the next 3 rollouts, where the robot should place the cyan box in a straight line with the blue and red box. Baseline 1 only optimizes for task success, so the preferences are usually not met. In this next example, baseline 2 failed due to an action that is slightly more preferable, but riskier. In the final example, baseline 2 only maximized for task success and ignored the human preference entirely. Compared to the 2 baselines, text-to-interaction reliably found successful plans that strongly aligned with the oracle behavior.